Desktop 2. Okay. There we go.
That's better.
Is that the one you're looking for? Who pays the development tax?
Yes.
Okay. So consider a city where the initial equilibrium price of housing is 200,000. The price elasticity of demand for housing is -1. And the long run price elasticity of supply is 4. Suppose the city imposes a development tax of 25,000 per dwelling. Illustrate the effects of the development tax on the housing market. Include numbers for housing prices with and without the tax, and the marginal cost of production with and without the tax, the portion not borne by the consumers. All right, so what'd you guys do on this one? Who wants to share?
I do.
Okay. Why don't you, do you got it pulled up on your screen? Was that JC that said that?
Oh, no, I took that with I did that on paper, but I can try.
Oh, you just muted.
I said I can try get it and then share it.
I can probably pull it up just as fast, so if you don't have it ready.
I'll try to be faster than you.
All right, we can both go for it, I guess. See what happens.
I said I cannot share screen while participant is sharing, so you can just get it.
You have it ready to share already? Yeah.
But you're right there, so it's all good.
All right. Throw the pictures over there. All right, chapter 16. Is it on the next one or is it in this one?
It's in the chapter picture one, sorry.
Okay.
That one, yeah.
All right, number 3. All right, so that's this one down here. Okay, you want to talk us through what you got?
Yeah, how I get the numbers is because it's like 4/1. This is my thought process of that. It says that the demand is 4 and supply is 1, makes a 5 total, right? So then it's going to be a 4/5 of the thing is going to get you the 220K, because then you got 200 divided by the 25K, which is the tax that they're giving, the 25,000, which gives you 4/5, and you times that by, wait 1 second, you times that 200 divided by 4/5, and then it gives you the 220K. That's how you get the values.
Okay.
And the same for the 195, which is the 5,000 that goes to the landowners, that the part that they have to pay, which is 1/5 of that, and then the marginal cost thing is $25.
Where's the 5th and the 4/5 coming from? How did you get that? I think that's kind of the key part.
I took it as like, because the elasticity demand is 4 and the supply is 5. I mean, is 1. So you added the 2 together, so you get 5 in total. So then the 1 is 1/5 and the other one is 4/5. So then that's how I put that together.
So are you using a formula for that, or how did you come up with that?
In the textbook on page, where is it? Page 252, it just does that.
Yeah.
And then I just worked up to the formula of that and just using the numbers that were given to us.
Okay. So that is what page did you say it was on the text? I'm
252.
252. So yeah, that's a kind of a known formula from different classes, and I couldn't remember if they actually had that formula shown in here or talk about the incidence of a tax. Okay, yeah. So following through with the way the book did it there, let me just add real quickly, if those of you who were, oops, I meant to not quit the share here. So you didn't really show your work really well here.
Yeah.
So, I mean, I would try to clean that up, especially for a test. But the share of the tax is the elasticity of one over the other. So the share for consumers of a tax, the share for consumers is the equal to the elasticity of demand over the sum of the elasticity of demand and supply. So this is just kind of a convenient formula that you can use. And this is you're adding these together. So it's really the absolute value of the elasticity of demand is always negative. So you're adding that together. So the problem said that the elasticity of demand was 4. And so that makes the consumers have 4/5 of the burden of the tax. So from JC's picture here, when you implement the tax, remember we can kind of think of it being the tax wedge. And the top part of the wedge touches the demand curve and tells you the price the consumer pays. And the bottom part of the wedge touches the supply curve, showing you the price the producer receives after the tax is implemented. So the vertical height, as is shown here, is the tax, little t, of 25,000. And so then you just take the 4/5 and 1/5 is the burden. All right, let me just open it up for questions if you want to verbalize, or I can try to watch the chat box too. Did anybody do it differently, or does that make sense?
Yeah, that makes sense.
Okay. And then just notice that if you, this formula is the same thing for the share for the consumer or for the producers. You just substitute in the elasticity of supply. So it was 1, and so it would be 1/5. I think, are your numbers flipped around there, JC, though? I thought, okay, supply of housing was 4. Yeah, you have it backwards there, JC. From the problem, it says the...
Yeah, but I was working with 3 in my head. I wasn't really looking at the...
Okay, well, no, what you have written in your paper is wrong, though.
Oh, okay.
The elasticity of supply is 4,
Okay.
and the elasticity of demand is -1.
All right.
It still turns out to be 1/5 and 4/5, but you kind of follow the share. All right, any other questions?
1C.
What's that?
1C, if we could.
Oh, 1C. Okay. Let's see here. Let me get back to, let's clear this out. Okay, so consider a 100 household neighborhood with a vacant lot that will be developed either as a house or an apartment. Each household's willing to pay $300 for a house rather than an apartment complex. The apartment builder has bid $100,000 for the lot compared to a bid of $86,000 from the house builder. All right, so skipping down to part C, suppose half, well, maybe I don't want to do that. Zoning for low density is, let's see, let me just pull up the answer thing here. So, oh, that's the wrong one. Never mind. I don't have the apply one open. That's what I was trying to do. Give me 1 second so that if we go over some other problems, I'll have it.
You can show my paper if you want to on the...
Okay. Sounds good. What the heck? It must be hidden behind my thing here. There it is. Okay. All right. I got the apply. And Daniel, if you want to get yours ready for a screen share, because I'm working on, I just want to pull up something else.
Okay.
If you have it ready. Okay, so zoning for low density is efficient because 116,000 is greater than 100,000. Suppose the neighbor permanent builder and outcome which will contribute.
Is he gone for everybody else?
Yeah, he's gone.
Equal. All right, I'm going to stop the share. And then Daniel, you can share your screen.
All right, just a
Russ,
second.
whatever
It's
you
loading.
just explained, you cut out completely.
Yeah.
Okay. I was mostly just reading off the answers, so I wasn't explaining much at all. I was waiting for Daniel for that. We should be good. Okay, so Daniel, are you trying to share screen?
Just a second. My internet's going really slow, but it's loading.
Okay.
I'm almost there.
Okay, happy 22nd birthday, Jess. Whoa, nice. Is it today or was it nearby?
No, it's today.
It's today. All right. So everybody unmute. We'll try to sing Jess happy birthday. So on the count of 3, everybody unmute. We'll see how this goes. It'll probably be a train wreck, but 1, 2, 3.
Happy birthday to you. Happy birthday to you.
Happy
Birthday, dear Jess.
Happy
Birthday to you.
Oh.
All right.
I'd say it wasn't as bad of a train wreck as I was expecting. So,
All right. Can you see this?
yeah.
Okay, cool. So, okay. So for number 1, here's what I did. Let me zoom in a little bit. Okay. So, did he want to know C? Is that right?
Yeah,
JC?
let's just cover C because that's
Okay.
what he asked.
Cool. I can explain that. So half of the households contribute to the dollar amount, which is little g. The Pareto efficient outcome as a Nash equilibrium if G equals $280 because the contributor is decisive. So that means the bid would then be $100,000 for a house, which would tie the apartment builder. And I got that because I did 280 times 50 because it said half of them were contributing the $280. And there's 100 households, so 100 divided by 2 is 50. That equals $14,000. And if you add that to the $86,000 original bid, you get $100,000. Does that make sense? I think he's frozen.
Arrow.
Yeah, Kyle, can anybody hear me?
I can hear you.
Okay, cool.
Yeah.
I think he
everybody else
froze
is just
again.
gone. Yeah.
Yeah, that was really weird. Dang.
Well, this is fun and exciting.
At least we got to sing happy birthday.
Agreed.
Anybody hear me?
Kind of.
Okay. Can you
Oh,
guys
I
hear
hear.
me?
Yes.
All right. Well, I don't know if my system or what, or maybe it's back and forth, but did you guys hash it out? It looked good to me. I didn't know if other people had other answers. Thumbs up if we're good, or chat box. Okay. All right. Any other problems from this chapter 16? All right. Hearing none. Let's see. Why don't you stop share? Or I think I can. Okay, there we go.
I got it.
All right. All right. So let's see. Oops. Yeah, I'm going to go back to sharing my screen. So we've got, wanted to do a quick review of what we got left here. Let's see if my screen is. So in mod 7, I made some adjustments. We've got 3 chapters left that we're covering to wrap up the term. So today we're going to start in on chapter 18, which is cars and roads. So that'll talk about congestion and traffic.
I am totally not having a good time.
All right. Well, I'm gonna give me a thumbs up. Can you hear me now? It just blipped back in. I'm going to actually try to change over to my hotspot because it was working the other day. So let me see if that does better. Okay, so while I still have, in theory, a good connection, let me try to go back. Okay, so in mod 8, that's the final chapter, the role of local government, which actually brings us back to chapter 20. So it's chapter 20 is the role of local government. Your final paper I have set due for the 29th, basically the finals week. So that is something you could get started on. I have the JSTOR mentioned there in this piece. And so if you want to take note here of the Russ Econ Rocks, those of you who've had me before for the JSTOR, the password to get into JSTOR, I sometimes accidentally leave around for students, and that was Russ Econ Rocks 1.1. So that will give you access to the JSTOR, which is what we did for those of you who had me for entrepreneurial and capstone or whatever. When we have a paper, that'll give you access to a lot more journal articles. I only have a fixed number of downloads, so you can open up the journal and have full access to it, but don't actually download it because I have a fixed number of downloads that I have with my subscription. So that's Russ Econ Rocks 11 for that. And any questions on the paper?
Is it case sensitive or anything?
Yeah, I think it's cap R. For
Where
Rusty.
where in the module is it like the instructions for the paper?
It is on the site here, and it was also on your syllabus.
Pretty sure it's in mod 7, JC.
No, it's mod 8.
Mod 8.
Yeah, right here. So it's kind of similar to what we did in entrepreneurial. You do have to have an economics journal cited, but any other questions? It's a little ways away, but you can start thinking about topics. Basically, you need to pick any topic from this class is the details. And you're doing what we call a literature review, which again, those of you have had me before, so you're kind of looking at journal articles that are scholarly. So you can include popular media journals as well, but the point is to look at kind of academic work on whatever topic that you're looking at. At the back of each chapter in the textbook, the author is pretty good about putting in references. So let me just hold up my book. So this is that chapter 16 that we just got out of on land use. And at the very end of the written work in the chapter, he's got references of academic work and academic journal articles that will give you more details on work that people have done. So at the end of each chapter, that can give you a good spot to look at some topics that you want to write on. All right, any other questions there? All right, I'm gonna switch over to my other internet, so hold tight for a second. Okay. It looks like it switched over. Are you guys getting me okay, or is it sketchy? Thumbs up for okay. Okay, well, that's good. That's really good to know if I can use my hotspot on my phone. That at least is good backup.
He
So
spoke
much
too
for-
soon.
There, I got exactly. I guess I spoke too soon. All right, it seemed to pop up right away again, but all right, maybe it was with the screen share. So we'll see. I'm going to try it again. Okay, thumbs up if you can see the screen okay. All right, let's give this a whirl. Okay, so chapter 18, cars and roads. So we have externalities. Somebody, let's chat. Let's see who can give the best definition of an externality on the chat box for an extra credit for the best externality in general. What's an externality? Chat box, extra credit on the line. The first best chat box I have. What is an externality? All right, let's see. Effects on a third party from a transaction that they didn't take part in, positive or negative. That's not too bad. Things you can't control but others can. That's not too good, Kyle. Something that affects you from the outside. No, that's too weak. An effect on a third party. Damn, Daniel. All right, so yeah, not too bad. Okay, Nate, an externality is a cost or benefit received by a third party that they had no control over. All right, so I think if I had to pick from these, Daniel's is probably the best so far. I would just do a friendly modification, I think, to Daniel's. So I like the way Nate, I usually start off my definition here. All right, let's see what Jonathan's pulling up here. Positive, negative effect on a third party that is not directly involved in the transaction. Boom. I like that, Jonathan.
Yeah, I call Google on that.
I don't even, is that really what Google would have on it? Go ahead, you guys go ahead and Google it. Okay.
It's just that I'm on my iPad and I'm typing like super slow.
And was it from your, so was it from your brain or your old notes or something or what? Because I don't think that is what you're going to find in Google. That's kind of a Russ McCullough one there. So it is from your brain. That's what I thought. I don't think you'll find it exactly worded that way. All right. Well, either way, I think I like Dan. We're going to give 2 extra credit points, 1 to Jonathan, 1 to Daniel. How about that? So Daniel and Jonathan. All right. So that's how I would start off. I think Daniel had most of the bits and pieces there. Didn't take part in, so they weren't involved in the transaction. So that is kind of our working definition. And so with this chapter anyway, with congestion, we're probably going to be talking mostly about negative externalities. And so when more people start to get on the road, that causes problem for other people. So the congestion is the externality. And so we're going to try to internalize the externalities with pricing. So this is where we'll get into toll roads and other things. Like if you're the one causing the problem, then we're going to have maybe a toll that we can assess for you. So here's some just general information. What causes us to travel. So 30% of your travel is social and recreational, and you go about 11 miles is the average trip length. So work-related, people tend to drive further for work. So 9% of travel for work and a 28-minute commute. And then going shopping, we tend to shop a little closer to where we are for most of our shopping, if you think grocery store and other things. So that kind of gives you at least a quick little breakdown of some of the content that we have. So one of the problems with travel by automobile is people driving alone. So in terms of efficiency, if we have more people moving from one point to the next that could be sharing, some sort of ride share or other thing would be beneficial in terms of congestion. Now, we're Americans, we like our car, we want to be maybe by ourselves and not have to feel like we got to talk to somebody in the car. Whatever the case is, that's not really what we're looking at here, but just look at how much people are doing. So, and this is for commuters to work. So here's Russ over here who walks quite a bit to the OU campus, 2.9%. So carpooling's pretty light. Taking the bus or the subway. I mean, obviously, if you go to New York or something, like Manhattan, New York, then you've got a lot of people using the subway, right? So that would be way higher if we just studied New York. But if we think about New York being and wash it in with the United States, then it's not going to be as big of a deal. All right. So there's another just summary of speed and distance, time, and speed. So we got from 1983 to 2001. So we've got different times, average length, average time, average speed. So speed has been the only thing that hasn't climbed up as we move into 2001. So that would be probably due to consumer safety and some other things. All right, so 47 hours. This is just kind of some fun facts from the chapter. So typical consumer, 47 hours in traffic. That's one reason I like my 30-second commute. I don't like traffic at all. I think most people don't, but some people just get used to it. Gasoline, this is extra gasoline. $5 billion because of traffic is what they're saying. So we end up spending a lot more money on gasoline because of congestion issues. If we add some time cost into it, 63 billion. Modeling congestion with commute distance, monetary cost of 20 cents per mile, opportunity cost of 10 cents a mile. So you can start estimating, there's papers that estimate the effects that way. And so here is our basic model of an externality. This is the same type of picture we used in previous classes, even in Principles of Micro when we did it, is you've got a private cost and you have the social cost. So the private cost of a trip is down here, and you are adding an externality, a congestion, to some other people. So when there's 1,600 people on the road, the amount of extra cost that you're adding on, going back to the definition that we started off with, you're imposing a external cost on a third party not directly related to the reason why you're on the road, right? So you're on the road to get to work or to get to the store to buy something. That's all part of your transaction. And now you're imposing a cost on other people not directly related to your transaction. So when we take into account the cost you're imposing on other people, then we have the social cost. And so the socially desirable, assuming that the demand curve, there's no externalities here, then the marginal social benefit is the private benefit curve, right? And so where the social benefit curve and the social cost curve intersect each other is at 1,400 vehicles on the road. And so that would be society's optimal amount of vehicles on the road after we take into account the externality. So that's just our standard model for an externality. Go to the chat box. What is this shaded area here? I'll even put extra shading. Yes, deadweight loss. Good, Jana and JC. So deadweight loss is there. And the other thing I might point out is that we usually got a deadweight loss when we had the government like impose a tax on a free market. And I want to point out that this is the free market outcome. So currently the free market without additional intervention is generating the deadweight loss. So the deadweight loss here is from kind of the free market with no intervention, because people are looking out for themselves privately, not taking into account the additional costs that they're imposing on others. Now, the answer to, or the possible trade-offs and solution could be some level of government intervention. Some of those levels might be better than others, though, and that's what we'll be exploring. 10-second pause for questions. All right. So we can do some calculations with all of the various parts to the problem, I guess is one way to look at it. So the author put this together. This is actually not in your current textbook. This is from the old edition, but I think it's kind of helpful to see what those numbers look like. The author in the current edition just shows the graph. And so I think this is kind of helpful to look at how those numbers are generated. So on A, we've got vehicles per lane of traffic, right? So we got the vehicle count going up. And as we do that, we've got trip time. So down here, column B, C, D, E, and F, and G is all highlighting what they are. So trip time increases with the volume. So here we've got the trips 27 minutes versus 12 minutes. Now notice here when it goes to 12 minutes, tell me what's going on in the chat box. When I have 200 cars versus 400 cars, the trip time is still 12 minutes. Why? And then it slowly starts to creep up as we move down. Distance and speed limit? No, it's not distance and speed limit. That's what Daniel put on. It's kind of a subtle point. Think about a freeway where we have 200 cars and now we double it to 400 cars. But yeah, it doesn't cause the traffic, right? So the highway can handle a certain amount of capacity, right? And so once we start to get incrementally above 400, we start to see a little delay. Now, this isn't too big of a deal, right? We're talking 12.47 minutes. So even when we get up to 600 right here, we've only added less than a minute onto our commute, which isn't too bad, right? We start to see a little bit of traffic, maybe traffic starts to slow down or something, but it's not until we get up to this level where it's maybe stop and go, bumper to bumper a few times, and then of course it only gets worse as we increase traffic. All right, so then part C is the private trip cost. So we're just gonna take a $2 monetary cost, $10 per minute, and the trip time to come up with a private cost of a trip. So that's just some assumptions. Notice then that it becomes more costly for you privately as it starts to get congested because you've got more trip time. Once the trip time starts to kick in, then it's going to become more costly to you privately. And then the increased time in vehicle per minutes. So this is for each vehicle. So for D, increase in total travel time per minute. So there gives our minutes. Now this is just looking at the marginal increase. So again, it was 0, for moving from 200 to 400 vehicles. And then that starts to allow us to generate the external costs. There are no external costs when there's up to 400, and then it starts to slowly get more expensive of the amount that we're having other people bear. And that allows us then to add the private cost and the external cost to get the social cost. And then here's just the demand curve that we had. All right, so let's see what this ends up doing once we get those pieces together. We're going to try to get rid of the externality by internalizing some of that pay. So we can have a congestion tax. So we have point I, let's see here, point I is right here. And that is the private benefit and private costs. So that is the current market outcome of 1600. And the optimal outcome where the social benefit and the marginal private cost intersect is at 1400. All right. So why would we use a congestion tax instead of some other tax? So one thing that we could do is charge more income tax and build wider, bigger freeways. Why would that maybe not be as efficient? So go to the chat box. I want to challenge you a little bit. So we start using an income tax to build wider roads, bigger, higher capacity. Why would we not want to use a tax that assesses the user? Why not use an income tax and just build bigger roads? Why is that inefficient? Okay, good, Daniel. So it's not going to affect everyone where an income tax would. So not everybody uses it, good. So people who aren't using it, that doesn't seem real fair. So there's maybe even an issue of fairness there. And good, Luke, I like that. That is exactly what we find, is that you're going to attract more people to the road and exacerbate the problem. So what we find is that when we make wider roads, we get more people on and we get right back to where we were. So people will kind of fill up. It's very similar to the idea of if you have a big house you tend to fill the space that you have, right? And so you go, oh, well, this would be convenient there, and we'll just kind of keep filling up things. So here with this little illustration of Lois and Hiram, so Lois can actually be made better off too with the consumption tax. So Lois is going to stop using the road when the user tax is high enough. And so she used to get some consumer surplus from the road. Remember when it was free? Then if we do a quick little demand curve here, Lois would use some amount of the roads and she would get some sort of consumer surplus. So there was benefit to Lois when the road was free. But now if we can take an income tax and lower it and become more efficient with a tax paid via a toll or some other form, then both Lois and Hiram can be made better off because they're going to be less people out there, and we'll get rid of the externality.
I have a quick question.
Sure.
So what would putting like a toll road alongside that road that's already there, like what would just putting a new toll road in do?
Places have done that, or they've added a toll lane or something. Instead of just making something wider, they'll add a lane that is now a toll road lane or something. And so that would help, yes. Basically, we want to get the people that are willing to pay more because of it's more important for them to get to where they want to be. We're just trying to do a little price discrimination, essentially. People who are the high valued customers, we need to get paying for it. And then they're going to take the fast lane, they're going to pay it, which is going to reduce congestion on the other lanes. So yeah, that's same type of thing there. Yep. Anybody else?
Gee, that makes a lot of sense now because there's a freeway in Tulsa that's like always congested during like 4 o'clock.
Yeah.
It connects to a turnpike, and then as soon as you hit that turnpike, everything starts to die down. That makes a lot of sense.
Yeah, it's kind of fun when you start looking at some of this. So let's see. I think we'll close with a few questions for today. So will the imposition of a congestion tax cause the city to grow or shrink? So if we think back to, we're going to use our model that we had before. We won't do it today. We'll save this for Wednesday. But will the imposition of a congestion tax cause the city to grow or shrink? What do you think on that? Let's go to the chat box. See who can come up with some comments there. Okay, so shrink. So usually our gut feeling is to think that, okay, taxes are bad. We're going to move away from taxes. But we saw with the previous slide that what did that guy, his name was Hiram on the last slide, what happened to him when he was able to pay a toll? Did he get benefit? He had some benefit. So, but not everybody would benefit.
Didn't Lois lose her benefit though?
Well, Lois had some because we were decreasing the income tax. So in that case, we had that. But if we now think of Lois maybe moving to another city or something, then we can have positive change in both. So we'll look at the effects of that next time when we look at kind of the two-city thing to see what happens with the utility curves as we move them around. So, all right, we'll call it a day there. Why don't you go ahead and read this chapter? It's a fun, I think you guys will like it. It's a fun chapter. So this is chapter 18. We're skipping 17, by the way. So chapter 18, Cars and Roads. And we'll see you on Wednesday. Peace out.